Good morning, you guys. It is morning where I am. I should say when I am. And this is section 9.2. We're looking at hypothesis testing. And in this section, we're testing for a population mean mu. That right there is mu. So if you look on page 437 of the Discovering Statistics textbook that you love so well, and you look at question number 37, this question is about text messages. So some report, blah, blah, blah report, that the American adults send a mean of 10 text messages per day. A random sample of 100 American adults shows a mean of 12 texts. That should take texts, not tests. Perfect. Assume that sigma, this is the population standard deviation, equals 20. Test with a significance level of alpha equals 0.01, whether the population mean number of texts per day differs from 0.10. So when you get these problems, and here you are sitting on a test, anytime you see this alpha level, it tells you you're dealing with a hypothesis test. That's pretty much the gist of it. So the problem looks pretty simple, and I'm going to walk you through the stages, how you want to draw the information for a test. So here I wrote the question again, and what I like to do when I do these problems is I like to write down some information before I get going. So the first thing I like to write down is this. What is the population parameter we're testing? So in this case, mu, that's a mu, equals the population mean average, that is, average number of texts, like Americans, per day. I could say the population mean number of texts sent by American adults per day, but I'm going to run out of room here. And when I read these problems, here's what I like to do so I don't get too messed up. I like to draw the information and write it sort of on the side here. So we know, let's see, a random sample of 100 American adults, so n equals 100, that's right there, 100 American adults shows a mean of 12, okay? That's saying that x bar, that's the sample mean of 12 texts per day. Oh, look, I wrote texts, that should be x texts per day. Test with a significance level, alpha equals 0.01, whether the population mean differs from 12. So one thing, the first thing you have to write on your test is H0 and HA. This is the alternative hypothesis. I can make it a big A like that if that's easier to read. So we want to test if it differs from 10. Differs from means not equal to. I usually write the alternative hypothesis first, mu not equal to 10, and then we're testing the null hypothesis, means it's equal to 10. So now we also have mu 0 equals 10. So in order to do this test, you need the test statistic, which is, your book writes this as z data. So I don't really like that expression, but I'm going to use it to be consistent. You need the p-value, because I'm teaching you the p-value method, and then we're going to make a conclusion. So to get the z data, you can do this on your calculator, which is what I would recommend, but here's the formula. X bar minus the sort of mean that is in the null hypothesis divided by sigma over the square root of n. So in this case, we can do this one by hand. It's not that arduous. 12, that's x bar, minus mu 0 is 10. That's the number that's in the null hypothesis. Sigma, oh, I forgot to write that down. Sigma equals 20. That's the population standard deviation. It's kind of weird that the average would be 10 and the standard deviation would be 20, but let's just go with that. I actually thought it was a typo, divided by the square root of 100, but apparently not. So when you work all this out, you get 2 on the top, and 20 divided by 10, which is also 2. This is nice, isn't it? So the test statistic is 1. Okay. The p-value, there's a couple of ways you can do this. I like to do it on the calculator, so I'm going to switch over here to this calculator method. So here we are, here's the problem. Here, I wrote this down again. Here's z data, there's the formula. Maybe it's easier for you to read that than my handwriting. So on the calculator, which is how most of your fellow students will be doing this. So you want to go to stat, right here, and then once you hit stat, you arrow over to tests, and then the first one here is one z-test. So kind of arrow down there, although it should be waiting for you, and then hit enter. And then for input, you have to highlight either data or stats, and you want to pick stats. Oops, I didn't highlight anything there. I'll do it in yellow, because all we have is the summary statistics. We have X bar and stuff. So then you type in these numbers. In this case, the null hypothesis number is 10, standard deviation 20, X bar is 12, n equals 100. And again, that's why I write these out, so that when you're using your calculator, you don't start typing in the wrong numbers. It's very easy to type in X bar and mu 0, switch those accidentally. So you don't want to do that. Now for this one, you have to pick one. What is your alternative hypothesis? Well, ours is differs from, so we're going to highlight this one, and then you arrow down to calculate, and you hit enter, like that, and the calculator spits out all of these numbers. Ta-da! Isn't this nice? Calculator, calculate, so I'm going down, making sure. Yep. So this Z right here, that's the Z data. That's what the book calls Z data. That's your test statistic. The test statistic. Oops. And then this is the p-value right there. And then X bar is 12 and n is 100. It's always kind of funny to me that the calculator gives you this. It's like, no, I gave you that, and it gives it back. So there you go. But here's the important thing. Z is 1, p-value is 0.31731. 31731. So over here, so we got same thing, 0.31731. As an aside, suppose you didn't want to use the calculator for some crazy talk reason. So here's a Z. I'm going to show you how you can find this by hand. Here's a Z curve, and we say our test statistic is 1, so it's about here. There's about 1. This area right there, let me get this way. This area here, I have to close it off. Dink. Right here, we can get on the Z table. No, don't like it. All right, well, I'll have to give that up. But right here, go to 1. 0.84, do you see right here? This is the Z table. And if you go to 1, it's 0.8413. So go back here. It's right here. Is 0.8413. That tells us that this little area, we'll make it yellow, is 1 minus that, or 0.1587. This little area there, 0.1587, because that's 1 minus 0.8413. So because our alternative hypothesis is two-tailed because of this not equal to over here, in order to find the p-value by hand, we have to multiply this times 2. Times 2, which is going to be equal to, wait for it, 0.3174. So this is all an aside of how you would do this by hand if you had to. You would essentially find the tail value of your test statistic, and if it's a two-tailed test, multiply it by 2. Most of you will not do this. Most of you will just do it on your calculator and get this number, and that's fine. Now, moving on. Our rule is reject H0. This is always the rule. Reject H0 if the p-value is less than the alpha level. That is the rule. So in this case, this is what you want to write on your test in order to get full credit. You say, in this case, p-value equals 0.3, you could just say 17, is greater than, here's our alpha level, 0.01. It's greater than that by a lot. Alpha equal 0.01. So you fail to reject H0. I'm going to have to go on to a new page. You're not done yet. If you stop now, you will lose about 2 points because you need to write the conclusion in terms of the problem. So, go to here. So here's how you want to write your summary. The conclusion. So you want to write it in terms of the problem. So include a sentence like this. Reject H0. That's not enough. Don't stop there. Right? There is insufficient evidence to conclude that the mean text messages sent per day by American adults differs from 10. So in conclusion, I'm just going to quickly circle in red the parts that you want to put on a test. So you want to put this on a test. Your paper should look like this. It should have this number on it. It should have z data equals 1. It should have p-value equals this. It should have a sentence that looks like this, the p-value, comparing the p-value to the alpha level. Oops. You know, in my other conclusion, I wrote it wrong. Here, I'll show you. We should fail to reject H0. So go back here. Aha. Fail to reject H0. There, I fixed it. And you want to include a sentence like this. So, that's how you do it. It's not as bad as probability. We just made a decision. Americans do not send a number different from 10. I think they actually do. Old data. Okay, moving on.